The next most basic function is our quadratic, our parabola. The reason these two functions are so important, every polynomial can be factorised down to be a combination of linear and quadratic factors. Everyone. So that's why these two, we spend so much time on these two types of functions, linear functions. And now let's have a look at our quadratic. And the graph of a quadratic, you may recall, is a parabola. Some definitions here, subtle differences. The quadratic polynomial. The quadratic polynomial is just an algebraic expression. And the highest power is 2. So you get ax squared plus bx plus c. That's the quadratic polynomial. Then there is the quadratic function. So it's different to the quadratic polynomial because now we make it equal to a dependent variable. So when we now say y equals, it becomes the quadratic function. And then that brings us to our third, the quadratic equation. And that's where we get the quadratic polynomial and make it equal to a number. And usually we make it equal to 0 to make life easier to solve things. But that then becomes the quadratic equation. So subtle differences between the three, they all are of course quadratics. If the coefficient of x squared, so the a, is equal to 1, we call it monic. So it becomes a monic quadratic, or a monic polynomial for that matter. Coefficients, well hopefully you know what that is, a, b and c in our case, they're the numbers in front of the pronumerals. Indeterminate, you might not have heard of that expression before. Indeterminate is the x value. Remember we said the x value was the independent variable, free choice. We can pick anything we like. So we can't actually determine what you're going to pick. So we call it the indeterminate. Roots, they're the solution to the quadratic equation. So they're the roots of the equation. As opposed to zeros, very, very subtle difference. The zeros are the x-intercepts of the quadratic function. So technically you have roots of an equation, but you have zeros of the function or the polynomial itself. So if I had a question which said, find the roots, it's saying find the roots of an equation. So it's saying solve for x. So, well, not exactly a difficult quadratic there. X squared minus 1 equals 0, so we get plus or minus 1. So they would be the roots of that particular equation. All right, we want to graph quadratics then. That's what we're talking about at the moment, graphing our functions. We know it's going to end up being a parabola. So there's our standard one. Y equals ax squared plus bx plus c. Now a, b and c all give us different bits of information. A, there we go, talks about what we call the concavity of the curve. So if a is greater than 0, that's concave up. You can think of it as a happy curve. Because look, it looks like a smile as it is. Happy, everything's good. Then we get the unhappy parabola, the sad parabola, where a is less than 0. So it has a frown, because it's negative. So we don't like being negative. Concave down, concave down. B by itself doesn't tell us a lot. So let's skip straight to C. C, the constant number, same as the linear function, same as any function. The constant by itself tells us the y-intercept. When I say any function, I should have said any polynomial function. So the zeros or the roots, depending whether we're talking about the equation or we're talking about the function, so they're the x-intercepts. Now, b by itself, I said, doesn't tell us a lot. B, when we put it in this form, minus b over 2a, so we combine it with the concavity, tells us a lot. That's the axis of symmetry of our parabola. It always turns out to be the average of the zeros or the roots. So if you've already found the x-intercepts, and you then have to find the axis of symmetry, you don't have to worry about using minus b on 2a. You could just average the two x-intercepts, or the two roots. The vertex, well, it lies on the axis of symmetry. So once you know what that is, substitute it back into the function and that'll tell you the y value. Now note, the y value is the maximum or minimum value of the function. So if they're talking about a quadratic function and they say, what's the maximum of this function? Or what's the minimum of this function? They're not talking about find the vertex. They just want the y value. How high up does it go? How far down does it go? That's the maximum or the minimum value of the function. All right, let's do an example. X squared plus 8x plus 12. I wouldn't necessarily write everything down that I'm about to do here, but I'm using it as an example. For instance, I probably wouldn't bother writing down, oh, A is equal to 1, so I know it's concave up. In my head, I'm thinking that, so now when I draw it, it should be concave up. This one, of course, I will draw. The y-intercept's quite important, so let's plot that one. There it is, up at 12. Let's find the x-intercepts, the zeros. Solve that. That's a nice easy one. Multiply together to give 12, add together to give 8, 6 and 2. So we know we're cutting at -6, -2. Plot those in. All right, starting to get a feel for what this shape's doing. The axis of symmetry. Well, as I say, you can do it one of two ways now. Yeah, I could use the formula, minus b on 2a. That gives me -4. Or I could just average those two x-intercepts that I just found. Again, we get the answer -4. However you choose to do it. Now, I would not normally draw that in. As I say, this is more for the sake of the example. We're saying, righto, I know we've got an axis of symmetry there. Let's find the vertex, sub into the function, and by an amazing coincidence, it also turns out to be -4. Let's plot that one. I reckon that's enough. We know it's concave up. It's got to go through those points. We know it's symmetric, and we can draw our parabola. Y equals x squared plus 8x plus 12. Well, what happens if they ask a question like this? We know the roots. We know the solutions to the equation are 3 and 6. So what would the quadratic be? I know it'll be something like this. Notice they just said quadratic. They didn't say what is the quadratic equation. They didn't actually say what is the quadratic function for that matter. I've made it a function though. Any multiple of that will work. So that's why I put A out the front there. Because where the question's worded, I know nothing about the concavity. So I can say though, it's going to be any multiple of x squared minus 9x plus 18. How did I get it so quick? Well, think about how we solve quadratics. We would have said what multiplies together to give the last number. Well, if they've given me the answers, then I know they multiply together to give 18, so the last number's got to be 18. And we would have said to ourselves, what adds together to give the middle number? Well, the middle number is -9. But think about when you're solving it. You would have ended up with a factor of, we would have got x minus 3. And so then the actual answer would have been x equals +3. So we've got to change the sign in the middle there. So that's the quick way of doing it. If I know the solutions are 3 and 6, to get the constant number, I just multiply them together. To get the middle number, I add them together, but change the sign. So then if I get something like that, the roots are 3 plus root 2 and 3 minus root 2. So they must have had to use the quadratic formula to find these answers. I don't have to waste time and go, oh, well, the factors will be x minus 3 plus root 2, x minus 3 plus root 2, and expand the whole thing out. I can say, well, hang on. There's my answer, because what multiplies together? Well, hang on. Multiply these two things. I've got conjugates. Difference of 2 squares. So 9 minus 2 is 7. The middle number, well, the surds cancel. 3 and 3 is 6. Change the sign. There's the middle one. So the 7 was the difference of 2 squares. And then when I add them together, we'll get -6. Or we'll get 6, but we'll change the sign. This time they've told us a bit more information. They've told us the roots, but they've also told us the vertex. So it's going to be some multiple of. Multiply 8 and 2 together, 16. Add them together, I get 10. So I'll make the middle one -10. I now know it goes through 5, 3. So let's substitute that in, and we'll see what multiple of that we've got. So I'm trying to find A. A in this case is, what's that, -1/3. So there's my quadratic. Y equals -1/3, x squared minus 10x plus 16. 3D. Notice for question 4 there, I've said use Desmos. Fantastic little package. If you're ever unsure what a function looks like, just plug it in and then you get a picture of it straight away. Okay, you can't do it in a test, but I mean, when you're working on your exercises, you certainly can use it to save some time.